Hello students, welcome back to classes on computer organization. Next is about the complete processor. See, complete processor organization, very simple thing. If you understand the diagram, you can easily write in your own words. You can find the bus here. See, single bus are right from the first module. We are studying about this. Just recall, we have a main memory, processor as well as input output devices. So single bus architecture is the one that connects all the peripherals like memory, processor as well as the input output devices or peripherals. So you can see the main memory and input output devices as a box. Then we have a single bus, right? This bus is also connects to the processor, but we are studying in detail about the processor. So processor has got a bus interface in it. Okay, see here, instruction unit. It has got an instruction unit as well as data unit. Okay, the instruction unit, as just before the instruction unit we have an instruction cache. Cache is the temporary memory, easily if you store the data in the cache, then you need to refer to the primary memory for the same, right? Easily you can access it from the cache itself. There is an instruction cache and data cache to temporarily store the data, to just to speed up the computation. We have an integer unit as well as floating point unit that comes under data cache, right? This integer unit and floating point unit, again just to speed up the computation, we are dividing the part into the number into integral part as well as floating point unit. Okay, that they are associated with the data cache. Very simple thing. We have a bus interface. This bus interface connects the cache, both the caches, instruction and data cache. So instruction cache has got a instruction unit, and here data cache connects to integer and floating point units. That is what about the configuration of a complete processor. Okay, very simple thing. Then we have a hardwired control and micro-programmed control. So what is hardwired control? Hardwired control, how to generate the control signal, why this is required? Hardwired or micro-program control, question comes, right? So far we have discussed about the control signals like Z out, PC in, right? MDR out, IR in, then R1 out, R3 in, such type of control signals. How to generate the control signal at appropriate stages? The question comes, right? They are generated by, there are two technologies to generate the control signal in sequence. They should not be generated randomly. They should be generated in a particular sequence. So there are two methods to generate them. One is hardwired control. It's not hardware. Okay, hardwired control, and other one is about the micro-programmed control. See, hardwired control. This is the combination of and or gates or logic gates, you can say. So combination of logic gates will produce the hardwired control. Okay, see, hardwired control has got a block diagram. Again you have to study this block diagram. It has got a, yeah, it is the synchronous operation we are supposed to follow. Synchronous in the sense, as per required, as and when needed, particular control signal should be generated, right? So there is a clock. Then we have a step counter, control step counter it is called as. This control step counter, this will generate the step ID or step decoder. This step decoder, in each step there are certain control signals will come one after the other at a T1, T2, T3 and so on in each step. That is decided by step decoder. We have a combination of instruction decoder and encoder circuit. They are associated with the instruction register. It may take the external input or conditional input. External inputs are nothing but like uh, pressing of a while transferring the data, pressing of a button, okay, or sending the additional data. Conditional codes are nothing but flag bits. They are the indicators. And finally, this is the outcome, control signal. Here the outcome is at down, you can see here, see, control signal. This part we will get the control signals as I told you earlier, R1 in, or R3 out or Z in, Z out or select 4 or select Y, whatever the control signal it is, in the particular sequence it will be generated. Okay. See here, Z in, this is just an example. So multi input OR gate you can see. Z in, how Z in is generated? T1 in OR operation with OR operation with, here AND gate you can find T4 and branch instruction. One more AND gate we have T6 along with some previously done add instruction, outcome of the result, sorry, outcome of the add instruction. So outcome of these two AND gates are provided as an input for the OR gate. So T1 or the compound result of T4 and up branch, that is the second operand. Third operand will be compound instruction of result of add with the T6. So in that case, in that way, Z in will be produced. As I told you earlier, control signal is nothing but a set or combination of logic gates. Using combination of logic gates or set of gates will generate the control signal. Okay, that is about the hardwired control. We have microprogrammed control as well. Okay, here is the difference between hardwired and microprogrammed control. Please go through the difference table. Here is the table. So compared to hardwired control, we have microprogrammed control. We feel microprogrammed control is easier, much easier, but in the microprogrammed control, operation is slow compared to, okay, implementation as well as operation. Its operation is slow because it is totally depends on software. Whereas in case of hardwired control, the computation is fast. Okay, using software, microprogrammed control are implemented, whereas using hardware or chips, this hardware control is implemented. So other differences you just go through. Okay, another probability, most expected question, you can consider this also. Differentiate between, whenever there is a question comes differentiate, you should answer them using tabular format. Okay, so about the microprogrammed control, let us discuss in the next session. In microprogrammed control, actually we consider each instruction as micro instruction. So far we have executed, we have considered PC out, IR in, so and so, right? So such type of instructions are called as micro instruction. So there is another unit comes, logical unit called as new PC for micro program counter. Okay.